In this lesson, we're going to learn about the power rules. Now remember, we're not going to be using a calculator. There are several power rules, so we will break this down into a few lessons. We will learn how to evaluate a power that has a zero exponent and a negative exponent. We'll also learn how to use the product, quotient, and power to a power rule to simplify exponent expressions. So let's recall what an exponent is. An exponent is simply shorthand to writing repeated multiplication. The base is the number that's being multiplied, while the exponent tells us how many times to multiply it. Sometimes we call exponents powers. So below we have the powers of 2. 2 to the 1, 2 to the 2, 2 to the third, and 2 to the fourth. So let's get started with making sure we understand the difference between expressions that look very similar but are very different. So you may want to pause the video and take notes on this part especially. So let's look at the first expression. We have negative 4 squared and we have negative 4 squared. So let me say that again. We have negative 4 squared compared to negative 4 squared. So let's write out what this really represents. When we look at the exponent 2, it is only attached to the 4 and not the negative. So when we expand it, we have negative 4 times 4. The negative is not part of the base. This is like an understood negative 1 out here. So we have 4 times 4, which is 16, times the negative. So we have negative 16. In this expression, the 2 is attached to the 4 and the negative. So the base is really negative 4. So we do expand the negative. It's part of the base. So we have negative 4 times negative 4, which is positive 16. And we see these two expressions are not equivalent. Our second example, we have some variables. We have a times b squared compared to ab squared. On the left side, the a has an exponent of 1 and the b has the exponent of 2. The 2 is only attached to the b and not the factor a. So we have a times b. On the right side, the 2 is attached to both factors, a and b. So we have a times b times b. These are not equivalent. We could have written it as AB times AB. With commutative property, you can write it in whichever order you prefer. Our last example, we have 2 squared over 3. On the right side, we have 2/3 squared. This 2 only goes to the factor of 2 and not 3. So we have 2 times 2 over 3, which is 4/3. And on the right side, the exponent is attached to both the 2 and the factor 3 because of the parentheses. So we have 2/3 times 2/3, which gives us 4/9. And these are not equivalent. So let's start out with the zero rule. It says any number or expression with an exponent of 0 always equals 1. So here is the exponent with a power of 0 rule. But I do like to demonstrate why this is. So let's take a look at the powers of 2, starting with 2 to the first. So we know 2 to the first is 2. We know 2 squared is 2 times 2 is 4. And then we're going to multiply another factor of 2 to give us 8. So you can see that we're multiplying by the base of 2 each time, repeated multiplication to get to our next value. So 2 to the fourth is going to be 8 times 2 is 16, times another 2 to get 2 to the fifth, which is 32. And then 2 to the sixth is going to be, times another 2, 64. So you see the pattern is just multiplying times 2 times 2. Now let's go backward. If I were going from 64 to 32, and I'm going this way, we're going to be dividing by 2. 64 divided by 2 gives us 32. 32 divided by 2 gives us 16. 16 divided by 2 gives us 8. 8 divided by 2 gives us 4. 4 divided by 2 gives us 2. And voila, 2 divided by 2 gives us 1. So you can see why any base raised to the 0 is 1. It simply is dividing by itself. Now, let's take caution like we were just looking at. Recall, we have negative 2 to the 0. So on the left side, the 0 is only going to the 2. My base is 2 with an understood negative 1. So we have negative 2 to the 0, we just said, is 1. On the right side, the base is negative 2. The 0 is applied to both the 2 and the negative. So we have negative 2 divided by negative 2, which gives us positive 1. So these two expressions are different, so be careful. So pause the video and try these. When we come back, we'll work them out together. Okay, 9 to the 0 is really 9 over 9, which gives us 1. Negative 9 to the 0 is negative 9 over 9, which gives us negative 1. And number 3 is negative 9 to the 0 power, which is negative 9 divided by negative 9, which gives us positive 1. Let's go to our negative exponent rule. Most of the time, you're never going to leave a negative exponent. And the way you simplify and get rid of the negative is you move it to the opposite location of the fraction bar. So if it's negative in the top, you move it to the bottom and take off the negative. If your factor with a negative exponent is in the denominator, you flip it or reciprocate it to the numerator and remove the negative. So let's take a look at why this is. So we know that 2 to the 0 is 1, 2 to the 1 is 2, 2 to the second is 4, and 2 to the third is 8. And the way we did that is we multiplied by 2. And then we saw that when we reverse it and we divide by 2, we get our expressions decreasing. So 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. Now let's keep going. So this time we are going, so if we move down our our next exponent, so we're going 3, 2, 1, 0, negative 1. So we're going to take the previous product and we're going to say 1, keeping our pattern, divided by 2. 1 divided by 2 is 1/2. So you can see 2 to the negative 1 is 1/2. Let's bring that out. 2 to the negative 1 is really 1/2. So what happened? You take this factor and you move it to the denominator and it becomes a positive exponent, and we have to have a understood 1 in the numerator, can't leave it blank. So let's keep going. If we have 2 to the negative 2, we're going to take 1/2. We're going to divide it by 2. 1/2 divided by 2 is really 1/2 times 1/2, because dividing is the same as multiplying by the reciprocal. So I reciprocated, and so we get 1/4. I think, let's rewrite that. 1/2 divided by 2 is 1/2 times 1/2. I was moving a little too quickly and putting the answer there, which is 1/4. So 2 to the negative 2 is 1/4. Let's do one more. Let's do 2 to the negative third. Let's just bring this down here. So what we're doing is we're taking 1/2, and I'm just showing the pattern here. Okay, I'm just showing the pattern. So 1/2 divided by 4. So 1/4 divided by 2 is really 1/4 times 1/2, which gives me 1/8. So 2 to the negative third is 1/8. Now look, let's notice this. Look at this and this value. So we have 2 to the 1 is 2, but 2 to the negative 1 is 1/2. Let's look at these two and compare these values. We have 4, 2 to the second is 4, while 2 to the negative is 1/4. You can see these are just reciprocals of each other. And then 1/8, which is 2 to the negative third, and 8, which is 2 to the positive third, they are just reciprocals of each other. So that is why the rule is if you have a negative exponent, and we're not talking about a negative base, just a negative exponent, you reciprocate and you move it to the opposite location and remove the negative sign. So let's do these 3 together and then you can try some on your own. So 5 to the negative 2. We have a negative exponent that indicates we need to move that to the opposite location, which is the denominator, and we have 1 over 25. 1 over 2 to the negative 4. This says the 2 factor needs to be moved to the top. That removes the negative. It's times the 1. We don't need it. And so we have 16. Now we have some variables. You simply look at the exponent and you just move the factor. So b to the negative 1 is not very happy in the numerator. They want to be in the denominator, so we're going to bring it down. If you want to put the positive 1, you can. I do not. Now we're going to move to a squared. The factor a squared is totally fine. It's happy where it is, so we're going to leave a squared where it is. C to the negative third is not very happy, so we're going to make him happy and make him positive, and by moving him to the numerator. So we have all positive exponents. Okay, pause the video, and then when we come back, we will work these out together. Okay, 9 to the negative 2 is 1 over 9 squared, which gives us 1 over 81. Number 2, we're going to reciprocate the factor of 3 to the negative third to the top. We have 3 to the third, and this gives us 3 times 3 times 3, which is 27. Remember, we're not using calculators. Now let's take a look at 2 problems with variables. G squared is totally satisfied with where it is. K is not, so we're going to move K to the denominator. H to the negative 4 is in the denominator. He wants to come to the top, so we're going to bring H to the 4th to the top, making sure we leave no negatives on our exponent. Y squared is totally satisfied. We're leaving y squared where it is. However, w to the negative third wants to move to the top, so we're going to move w to the third, making it positive, and x to the 4th remains the same. Okay, we're going to come back and finish up the last part of this lesson.